Good afternoon, everyone. Welcome to the Construction Innovate webinar series on modern methods of construction. This week, we're going to focus on design considerations for modern methods of construction. My name is Jamie Goggins. I'm a co-director of Construct Innovate, which is Ireland's National Research Centre for Construction, Technology and Innovation. We're running this webinar series and associated with Engineers Ireland. As I said, this week is on modern methods of construction. It's the sixth webinar in this webinar series, with two more to go. We're delighted to have three fantastic speakers who all have a lot of expertise in this area. Our first speaker is Stephen Finn, who's Principal Engineer from Evolution Innovation, and he's going to talk about optimizing the design workflows of modern methods of construction projects. Then we have Tim Pettigrew, he's a Director from Reddy Architecture and Urbanism, and he's going to talk about design considerations of MMC and a case study, so from the architect's perspective. Now we have Eoghain Ryan, Director of Ryan Associates, and he's going to talk about fire engineering considerations for MMC. So we have a nice broad range of different perspectives, from the structural engineer's perspective, from the architect's perspective, and from fire engineer's perspective in terms of design considerations for MMC. So we're going to have our three presentations, and then after the presentations, we'll have a Q&A session. So we'll have the three presentations first, and then we'll have the Q&A session at the end. If anyone has any questions for any of our speakers, please do pose your question in the Q&A function at the bottom of the screen. And as I said, we'll deal with all those questions at the very end. So without further ado, I'm going to hand over to our first speaker being Stephen Finn, Principal Structural Engineer of Evolution Innovation, and talking about design workflows for MMC projects. So over to you, Stephen.
I'm Stephen Finn, as Jamie said. I'm a Principal Engineer here with Evolution Innovation. I'm going to be talking about optimizing the design workflow for MMC projects. And just a little bit about Evolution. So Evolution, we're design consultants specializing in 2D, LGS, and 3D steel modular construction. We have four departments, our primary departments in Evolution: the structural engineering and BIM, building performance and sustainability engineering, structural fire engineering, and product development and R&D. Our mission statement here in Evolution is to become the biggest and best MMC offsite construction consultancy in the world. So a little bit about myself. I suppose from finishing college, I have 4 years experience working with a main contractor in Ireland and the UK, and getting a lot of, a lot of very good site experience. And I saw a bit of MMC construction, I suppose, when I was on site as well. From a practical point of view, how it all went together, really interesting stuff. I have 7 years experience now here with Evolution, focusing on the structural engineering design of MMC solutions. I've project managed numerous LGS and steel modular load bearing schemes from tender stage to completion across Ireland and the UK. Continuing working on R&D projects for the LGS and the 3D modular systems. Continued improvements of QA standards, both within Evolution and I suppose across all our clients. And I'm involved fairly significantly in the structural and fire testing of MMC systems with our product development department. So I'm going to start off, I suppose, by highlighting the REBA stages, highlighted over in the UK. So this is your standard kind of project workflow. Similarly, in Ireland, we have the RIAI standards and the similar work stages, but I suppose I'm only really highlighting these that stage 0 to 4 is our design work stages, and they are typically identical, I suppose, from stage 0 to 4 and throughout the design coordination stage. So I'll be mainly focusing on stage 0 to 4 here in this presentation. So I'm going to use the REBA stages just as an example, so that I'm not back and forth between the terminologies. I'm just going to use the REBA stages. So as I said, stages 0 to 4 being the primary design stages and design coordination stages for MMC projects. And what I want to highlight at the start, and I think it's kind of what I'm trying to get at, is the collaboration at early stages and involvement of all key design team members between stages 0 and 3 is critical for optimizing MMC output and avoiding misinformation, late stage redesign, and on-site remedial works of off-site manufacturing solutions. Stage 0 to 1 is your typical tender outline requirements, typically done by an architect highlighting client requirements and I suppose going in for planning permission. Typically, and I suppose it's changing in more in more recent times, but typically these initial schemes were done with more traditional design methods in mind. And MMC options are often considered after planning has been confirmed. And I suppose we're looking at different MMC solutions after the fact, which we would prefer that not be the case, but it's perfectly fine to adopt an MMC solution at stage one. But again, typically traditional design methodology at early concept stage. So when we get to REBA stage 2, we would typically see that MMC options might be looked into, and our traditional workflow following the REBA stages would typically see an architectural layout being assessed by a fire consultant, and a fire strategy drawing again being created either in tandem with the structural scheme or before the MMC option is being assessed. Typically then what we get is a fire strategy drawing that is again based off a traditional design method and not an MMC design solution. The issue with this is there's no real coordination between fire consultants and the MMC structural engineers or the system owners, and there's no real collaboration between the tested system and the fire strategy at early stages, which can cause a lot of back and forth and a lot of confusion as to what the fire strategy actually should be. So as an example, this is being a typical architectural layout. What we would want to see is the structural scheme complete first and the MMC option looked into at early stages. And then from that, we take the system information and the tested information from whatever MMC solution is proposed, and we then go work with the fire consultant to take your traditional fire strategy drawing and readjust it and have a more holistic, collaborative approach to our fire strategy drawings, highlighting, I suppose, the load-bearing wall elements for this as an example, 2D LGS structure, highlighting the load-bearing wall requirements and their REI requirements as well. So, as I said, proposed design workflow what I see we should be doing is getting the architectural drawings, then identifying the elements of structure, and then doing the collaborative fire strategy drawing in line with that. That then will ensure that our fire consultants are provided with full structural schemes and layouts, or appropriate structural schemes and layouts, and the structural engineers are provided with minimum fire resistance periods for the elements of structure. What the structural engineers and the system owners can then do with their tested information, when we have this kind of collaborative fire strategy, it easily identifies potential outliers or gaps within the initial testing information from the direct field of application, and we can then do desktop assessments on increasing those fire tests to ensure that we're suitably covered and we're suitably designed, whether they be initial one-sided desktop assessments or more advanced two-sided fire resistance assessments. So for stage 2, that's typically, I suppose, the design workflow I would like to start to see, and it would just avoid a lot of confusion, especially around fire strategy at early stages. Benefits of these workflows: more collaborative approach to fire protection within the fire strategy drawing, aligning with the manufacturer's tested information, and limitations to test information will be reviewed and extended if necessary. It provides more comfort for the installers, client, and end users, ensuring that the strategy has been suitably considered and confusion between fire strategy drawings and the manufacturing test limitations are considered. And site-specific key junction details and fire protection concerns, I suppose, are more evident when you have that more collaborative fire strategy drawing approach. Everybody in the design team can highlight potential gaps and potential concerns that we may need additional boarding protection or fire protection for. So I suppose that highlights the changes I would make in stage 2 concept design. Stage 3 spatial coordination. Then again, we have similar issues with early stage coordination or early stage collaboration. So a traditional design workflow, what we typically see is the architects and the structural engineers for these MMC projects working quite well and collaborating quite well at early stages. However, down to multiple different reasons. There may not be kind of M&E consultants on board at early stages, or ancillary designers or ancillary design intents kind of highlighted at an early stage. We may have basic tender information, but in particular around the M&E service penetrations and clear working zones for the M&E. Quite often that needs a fairly detailed review, and I suppose getting basic tender information quite often wouldn't be enough, especially if we're going into manufacture of these structures. And so basic tender information given an early stage design intent for ancillary systems, but specific requirements not considered in later stage is a risk. And again, quite often due to time constraints on projects and due to for whatever commercial reasons, it's sometimes on projects, M&E consultants and these ancillary consultants may not even be appointed while we're being requested to proceed with stage 4 detailed design of our systems and detailed coordination. I suppose coordination with detailed technical design. This can result in coordination of M&E and ancillary information too late. Quite often, well, not quite often, a couple of times I have seen a M&E coordination or finalized M&E coordination and service penetrations happening at stage 5 after all of the structural frame is manufactured and all of the proposed service penetrations and service routes. I suppose a lot of changes need to happen, and remedial work is required on site then to address these issues. To avoid that, nobody wants to be doing remedial works on site. It kind of negates the point of MMC construction in general. And to get by that, I think we need to start adopting a more collaborative workflow at early stages, involving the principal contractor kind of managing the ancillary designers, whether it be your facades or your lift designers or precast stairs or something like that. Typically things that aren't showstoppers. But still, we would like to get initial design intent from engineers, architects, and everybody's point of view to ensure that we're manufacturing the right product. At early stage, at stage 3, I would like to start to see more M&E designers and installers appointed, and I suppose a more robust amount of detail for service penetrations and service zones. And that way, I suppose, between the principal contractor, the appointed M&E designers and installers, structural engineers and architects, we can all work holistically at an early stage and actually collaborate for the best product that we can manufacture, and I suppose avoid any on-site remedials and manufacture the exactly right structural frame, so that we're not having to do any rework. I think there should be a whole point at this point, either managed by the principal contractor or by the assigned certifier. Quite often, a lot of projects, the assigned certifier might be the architect on a project, but it's just a whole point that if all your designers and responsible parties there on the left-hand side are being held responsible, and I suppose sign off a structure or sign off that they have suitable RFIs answered and initial design intent received from all parties. Creating that whole point will give all of our designers more comfort to proceed with the design without having to worry about potential rework of design or, as I said, remedials on site when it may be too late. Doing this, then we're all proceeding with very little risk, if not no risk. No rework will be required in the design, speeding up the design process, and detailed coordination for manufacture should be complete, and there should be no issues on site. Then we wouldn't want to be issuing any manufactured material to site, knowing that there could potentially be changes. So progression of detailed design for all members of the design team can be complete efficiently without rework and reverting back to stage 3 spatial coordination changes. Reverting back to stage 3 when we're already in manufacture spatial coordination is always always a mistake. It always causes stress and unnecessary stress to the entire system. So the benefits of these workflows: all members of the design team are involved at early stage coordination, discussion, working collaboratively to provide the safest, easiest to install, robust and cost-effective solution. Rework of off-site manufactured MMC solutions can be reduced, if not completely removed, ensuring the maximum amount of factory-controlled construction. And additional remedial designs and preliminary site costs for remedial works on site can be reduced. And finally, the seamless design approach will contribute to the overall quality of the system and ease of installation on site. These are all massive benefits, and you can imagine the amount of rework and the amount of remedials that might need to go on site if you're not doing that early stage collaboration. A couple of closing notes. So quite often the industry tends to manage projects assuming a traditional design method is being considered and naturally adopt a design build methodology. This is not through any fault of anybody other than this is what we've been doing for years, and adopting that approach is just come second nature to us. I struggle with it sometimes myself, but we do need to think about front ending a lot of that design coordination. MMC and off-site construction requires early stage design collaboration to ensure the system is suitable for use when being manufactured, with all design considerations allowed. And any member of the design team that defaults to the mentality that changes can be made on site or the design scope can change after REBA stage 3 could negatively affect the suitability and hinder the benefits of MMC construction. This is not anything new to us. The RIAI DFMA report in October 2022 has actually highlighted something very similar. So they've stated to participate appropriately with DFMA and MMC, the design team should invest early in understanding and reviewing the various products, methods, and options available. Early engagement with contractors, manufacturers, or products representatives will inform the design team of the various requirements of a preferred method of construction or options on manufacturing assembly, which can be embedded within our design from inception. This knowledge will inform the development of a project brief, which will enhance how we visualize, design, draw, and ultimately create a building or scheme in the future. Now, when these projects go well, we have a couple of examples of when these projects go well and are coordinated well. This is a 4-story 2D panelized structure in Leixip we've done for Cairn Homes. Here is a 3D modular structure, fully finished, fully kitted out. It was basically a plug and play modular system for additional apartments, rooftop extension in London. The only site works other than where fire barriers, installation of the modules, plugging and playing into the service routes, installation of the fire barriers along the external edges and the external cladding. Everything else on that project was completely designed and manufactured in a factory, and it worked quite well. Then we have another example here, Bandon Road student accommodation there in Cork for Clancy's, and St James's Hospital then in Dublin as well. We've again another 2D panelized system. Thank you very much. I hope that was informative for a few of you anyway. I'll take any questions there at the end, I suppose, and I'll hand it back over.
Brilliant. Thanks, Stephen. That's a great overview of the workflow, and I suppose highlighting the importance of early engagement of the designers, the system owners, and the contractors for successful delivery of projects. So if anyone has any questions for Stephen on that presentation, please do post them in the Q&A at the bottom of the screen, and we'll deal with those at the very end. So our second presenter is Tim Pettigrew, who is Director of Reddy Architects and Urbanism, and he's going to give us a case study from their perspective, from the architect's perspective. So over to you, Tim.
Thank you very much for the time and the opportunity to talk about this. We are going to briefly go through one of our major projects here in London. I run the London office and have been developing the large-scale projects we do here. The reason I'm taking a single one is I believe that MMC is such a broad and wide pantheon of opportunities. It's understanding which system you're going, what the benefits are, and working out at an early stage what the implications are. So this project is down on the east of London, right beside the Millennium Dome, part of Ballymore's major construction development down there, Riverscape. Ballymore have done 4,500 units at Riverscape, and our development was almost 1,000 units on the western end of that. Ballymore used a system called the Builder system, where we used panelized prefabricated facades, which were structural facades. They also produced the structural pre-panelized slabs, panelized stair cores, and prefabricated stairs. So in essence, each of these blocks were able to be installed by 3 people and a crane operator about a floor a week. So it's a very safe system, and there's some specific benefits to this one, which is why we chose it for this area. Now, in terms of the 10 buildings that we've developed, the 6 on the right-hand side from plot 3.1 to the end, they were all done using the Builders system. The others were produced through a traditional system, and it was quite interesting to see the two methods being done at the same time and being able to compare. The Builder system has a sort of an aesthetic that comes out of it, which is quite a flat facade, but that's been accentuated by the architects who did the concept design. We took it on post-concept, redesigned a lot of the interiors, redesigned the fixtures, fittings, and created the engineering solutions. One of the key issues of this is the area that we're in is very acoustically challenged. We have working wharves down across the water, which are digging out silt and gravel from the barges that are delivering it up for the construction industry around London. Therefore, there's a lot of heavy noise at different reverberation times and different levels of the acoustics. One of the benefits of the Builder system is because it's got a concrete internal layer and a concrete or brick slip external layer, it has an incredible acoustic mass to it. It does, however, have a thicker wall, which then gives you the opportunities as an interior designer to create lovely seating areas along the walls and create a different aesthetic that we're able to achieve. Builders has been something that Ballymore have been involved in for a while. It's a Belgian company, and they do quite a lot of work with Ballymore. So Ballymore have delivered the London City Island scheme, which was their first major scheme using this system, and have developed it since then to move forward. What we've done with this is, building panelized facades is obviously most efficient when you've got it standardized elements. When you're looking at the ground floor, that's obviously not so standard. You've got changes in floor levels, you've got impact of different facades, different entrance sequences and everything. So what we've done in this scheme is taken the basement level and the ground floor level in traditional construction methods, and then we've jumped from that level, first floor slab, through to the roof in the panelized facade system. One of the key things in MMC to me is getting a client's conviction at an earlier stage, committing to it, because the structural solutions that come out of the Builder system in particular, and every system that you use in the MMC is different, requires a different structural basement, different piling strategies, and different weight loads. So the Builder system is quite a heavy system along the facade, but it does take out a load of other weights from within the buildings because there are no columns. So all we had was cores and facades, and everything else was picked up by transfer slabs that were picked up on the prefabricated panelized system. That made it a very different structure. So as you can see, the top levels all repeat, all stack on top of each other, very simple. Beauty about Builders and working with these guys is you can go and have a look and play with all their materials. They do have a standardized selection. Obviously, you can work with that to develop it. They do have the capacity for finishing in very different aesthetics. So from brick finishes to textured concretes to smooth and polished concretes. There's a lot of different solutions. And going to the actual site where they're creating this concrete is really quite entertaining to look at the actual recipe that goes into your specific building. So you can really tailor the size, the aggregate, the color of the aggregate, the mix of the concrete, and create a very strong aesthetic. That being said, we can also do brick slips, and this was one of our earlier schemes. And as you can see in this, we've got this double layer of concrete. There's the structural internal layer, and we've got this brick slips on the outside that carry it. It does create a fully filled cavity as well. So in terms of this, it's an encapsulated facade. There's no cavity. The fire risks are a lot less. We've obviously got the structure on the inside, which is very good. And it's all held up by these small corbels that sit in this area here to pick up the prefabricated concrete slabs. There is then a small screed / concrete binding layer that ties in all of the different panels together. With this solution, you obviously have to design in serious coordination with the MEP contractors beforehand, because when they come on site, you've already got the built-in ducts that go through the facade. All of this has to be early stage design. Likewise, the other system that we had on the same development was we had a concrete facade. This was polished to a specific level, quite smooth, and this was able to get us a similar element. So from here, you've got this stepped edge, which is great for weatherproofing. Sits on top of the lower level, which is part of the lower unit, and again the hollow core slabs. Now these panels came with their windows in place, with everything in place, which was great. Standard reinforced concrete backing, and you're able to go and inspect, check the quality, make sure that it's comfortable before it arrives. We created these in an accentuated double-sized panel. We were able to use that to highlight the grid pattern of the scheme, and bringing these massive panels into the factory where they were polished by the main polishing machine to get down to that grit level and that smoothness that you wanted for creating a longevity of the finished surface. As you can see on the left, it's pretty bland and grey in the concrete as it comes out of the shuttering, but when we were able to get it polished, we were able to pull out that aggregate level to the sort of the texture and luster that we were really looking for. As you can see, then Windows started putting in great mock-ups we were able to produce. We were able to find some of the issues that we came across during that early stage. Now, builders who were developing it, they would have tie-ups with different facade and window manufacturers. So we were able to work very early and get the details done at stage 3. And really, within the architectural point of view, our work within the RIBA stage 3 on the facades was actually reduced because we were able to rely heavily on the input of the trade contractors at that point. Our role became more of coordination. As you can see on the top right here are the 3 guys. Here's the panel arriving. One crane operator drops it in, a couple of props get attached, they walk away, get the next panel and get going for the rest of the facade. So literally a whole floor plate is put up in 1 week. Again, this is the reinforced concrete traditional base, and we built off that, and these were picked up on the slab edges and built very quickly. It does create this funny aesthetic. Everybody's used to the construction where the stair core is built to the top and then you start building up around it. This is a much safer system. We've got, as you can see, handrails going around the outside while the men are at work, panels going in place, and you can see the apartment shaping up in behind on the floor below. And this is midway through this block that ended up being a 17-story building. We also did prefabricated concrete balconies on this. They were again lifted into place, connected, so drainage was built in, finishes were off-site, and it was a really, really successful system. As I said, it does create an aesthetic, and although we look at the movement joints and trying to pick that up, we did actually use the movement joint across the top in certain locations as well, and we worked on the whole system with the cladding contractor throughout this process. In terms of looking at it, as you can see, we started these traditional blocks on the left-hand side, not really photographed here, but these were started about 12 months before these guys over here on the site. So the speed of the installation was quicker. Now that gives advantages to the different types of occupants as well. For a main private sale property, that's obviously going to be a slightly negative, that you've got this massive influx of properties coming on the market at exactly the same time. It's a little harder to get people to move in. For student resi and build to rent, it's obviously really beneficial because you want people to be able to move in quickly towards the end. The site was handed over in October 2024, and this ended up being about 9 to 12 months ahead of schedule. And the cost security that the client had also at that early stage in terms of the majority of the works really helped them. It is more expensive, But the added advantage in this location, close to the working wharves, meant that they were able to bring the project forward, get off the loans that they have on the land, and start actually getting money in for the properties and the occupants inside. It's been a really successful project for us. We've been able to deliver it on time with Ballymore, and they've been very happy with the solution. As I said, this is one of many examples of MMC, and I think we have to take it as an early approach and really educate our clients to talk about what are the benefits and why we should choose one system over another. Panelized facades, CLT, full volumetric, they all have different benefits and disadvantages. Having these elements built off-site increases the quality of construction, which ultimately means that we're going to be able to get better fire safety. Now, this particular building was built before the Grenfell impact happened in the UK. So the systems that we're going through now with the new legislation, where we have to make earlier decisions in the UK to sign off the construction methodology, get that all completed, is actually going to help us and help the MMC industry, because it's an industry that's already sort of embraced that early involvement in design. So I do hope that that helps, and I'm more than happy to have any questions either at the end of this or as a follow-up if people want to contact me in relation to this. Thank you.
Brilliant. Thanks, Tim. That's exciting project to showcase, I suppose, in terms of you know, its capability in there, but the reasons why, I suppose, the drivers why the client might have gone for that, even though it might be somewhat more expensive in terms of the construction costs, but why they do it and what the benefits are, and how it might work. So brilliant to see it in action. So without further ado, I'm going to go to our third presenter. So our third presenter is Eoghain Ryan. So we're going to get this design consideration from the fire engineering perspective. So over to you, Eoghain.
I'm going to touch on a few of the points the guys made, and there's a few crossovers, and I just go through what we're seeing on site and in design with regards to fire safety and compliance with Part B of the building regulations. Hi, my name is Eoghain Ryan. I'm a chartered engineer. I'm in self-practice for over 20 years and a former assistant chief fire officer. We specialise in fire safety, accessibility and science certification. So we were established 18 years ago and have 12 engineers, and we consider ourselves, whether it's true or not, to be a leading consultancy in this area. We specialise, as I say, in fire safety, accessibility, engineering, energy and building certification. I've presented in the Dáil on compliance with Part B and technology, and also in Westminster to the Home Office and DCLG on fire safety. So recent updates and recent advances that we've seen in MMC, we deal a lot with LGS, we deal a lot with timber frame, a lot with SFS and panelized systems. But we've just recently, I think it's the first commercial building in the country where we've obtained a fire cert for a CLT type system, where the building will have CLT walls and floors using a glue lamp structure. We found there was no agreement cert for the building, so we justified the structure using European technical assessment, and it was accepted. It justified the fire resistance and the requirements therein. It is a two-story crash and community hall. A part of the agreement as part of fire cert was that all the walls needed to be boarded except one large exposed wall, but they look for factory impregnated class 0 lining on this wall. So the timber was factory impregnated with the class 0. Recently, we have won, besides this, is 2 appeals on it to remove basements, remove sprinklers from basement car parks. They're becoming very prevalent in a number of local authorities where they condition sprinklers to basement car parks, particularly in residential, because of EV chargers. Just to give you an update, the Part B, the building regulations, was introduced originally in 1992, and then there were subsequent amendments to Technical Guidance Document B in 1997, 2006, 2019, and the most recent one was is the Part B to 2024, which has transition arrangements, which means any new building after the 1st of May 2025 needs to comply with the new Part B. It introduces a series of new measures and new requirements, and which can limit MMC above a certain height. And it will have implications for designers and people who are looking to use this as an end product. Key changes are where you have residential buildings over 15 meters, any apartment blocks over 50 meters, or hotels, you will need domestic sprinklers, and any residential institution homes, I.E. nursing homes with more than one story. That means if it's a 2-story or if it's a ground floor with a lower ground floor, that also requires sprinklers, domestic sprinklers. It also looks for, at the junction of the floors and the external walls, that there's you maintain fire resistance for 900 mil over that junction. This can have an implication, particularly in commercial buildings, office buildings, and the only way to get over that is to provide sprinklers. So it wouldn't really be relevant for the housing market, depending on whether you're going for large glazed elements, but it definitely has it'll have a factor for commercial buildings. It also looks at, this is what will affect the likes of MMC, it looks at compartment walls above 11 meters need to achieve a class A2 build up, therefore limiting the use of the likes of ICF and timber frame unless a test is provided to ensure that the build up achieves this. So I know we're working with a number of ICF companies to see if they can get a test on their build up to achieve this, and they're actually talking to Evolution about that as well. And then another requirement is for external walls above 15 meters. Yeah, again, you need the external wall build up needs to achieve a class A2 build up, therefore limiting the use of the MMC. So for the external wall build up, you have to, it's the full wall build up, not just elements thereof or the external facade. Another implication of the new Part B is dry mains are required where compliance with table 5.2 cannot be achieved, and that's becoming more prevalent. It's not really a massive factor for MMC, but it does affect the design of buildings. Again, this is something that's going to have to be factored into design and ceiling heights, because you're going to have to factor in domestic sprinklers, particularly in residential blocks over 15 meters in Ireland. It's over 11 meters in the UK, and the new BSR in the UK, they look for that. And as Tim touched upon, everything has to be front loaded before construction can start. It's a similar process to our BCAR process, but in the UK, they look for that. It's called a Gateway 2. After you have an initial planning approval through Gateway 1, everything is front loaded prior to construction starts. So construction starts post approval in Gateway 2. And it requires above 11 meters, you require domestic sprinklers. But here in Ireland at 15 meters, it does allow greater design flexibility with open plan design and greater distances to stairs, so you can minimize the number of stairs, and allows then for reduced structural fire resistance in some areas, and also then the requirements for external fire spread. So there is allowances there, and that will all help with regards to construction using MMC, but the limiting factor is the compartment walls and external walls. So you must achieve the Class A2, S3, D2 rating for compartment walls above 11 meters and for external walls above 15 meters. So that means the party walls need to be considered like non-combustible or of limited combustibility to Class A2. And that's very hard to achieve for the likes of timber frame and for ICF unless they provide appropriate certification and testing methods in accordance with the regulations to meet that. The pros, it allows in terms of what people consider to be more robust, safer design. Obviously, the disadvantages is increased costs and limits the use of some MMC above these heights, and that's a limiting factor for people in their design and when they want to go forward with an MMC, because the benefits of MMC are excellent and far outweigh a lot of traditional builds, but these all have to be factored in at the design stage and an early design stage rather than at the end. So everything is kind of being designed. The front load of design seems to be coming more and more to the start before we get to site, and we're noticing that on site. And this is showing you the impact of the junctions of external walls, where they're looking for that you have to be 900 mil over the junction, or it extends out, or you provide domestic sprinklers. Again, it provides more robust design for external fire spread and limiting fire within the compartment. But obviously the disadvantage is you can't have floor to ceiling glazed elements unless you provide sprinklers, which again has an added cost for the developer and the development. Again, what we see in the market and what we've been dealing with, particularly in the residential market, is modular pre-built homes. You have your volumetric MMC, panelized MMC, and then sub-assemblies. So we're seeing a lot more of these on site, particularly in residential developments, for terraced houses, duplexes, and small apartment blocks up to being 3, 4, and 5 stories. Again, everyone will be probably familiar with timber frame, ICF, again, LGS, SIPs, and mass timber. Mass timber is only really coming into Ireland at the moment. It's been used in one-off housing, but now in the advent of our successful fire cert and proving the ETA calculations, we think that it'll start to be accepted a lot more in the market. But fire departments by nature are conservative unless we can provide appropriate certification for types of structures and types of build. They generally revert back to the tried and tested and proven methods of construction. So while people want to progress with MMC, sometimes the limiting factor is at the fire department, building control department, or insurance companies. I know for a long while, ICF and some, and particularly ICF, what wouldn't be underwritten by insurance companies, but now that consideration is gone and they're fully underwriting it because it's a mass concrete core, and you wouldn't have, in general, a ventilated cavity on the outside. The benefits of MMC, as we all know, are the quality, offsite, dry, machine-made, more precision, the speed, the cost, particularly with the reduced cost times of construction. So the cost of finance and delivery times are increased. Health and safety and environmental benefits, less waste, more precision, well insulated, better energy efficiencies. So just going to go through one or two things. Like for fire certification, timber frame companies have created their own testing and Irish standard with the Department of Housing to IS 440. This is essentially a white book for timber frame. If they construct in accordance with this, they will fully comply with fire safety. Unlike them, other systems have to go through arduous and costly testing, and they have to obtain an NSAI cert in Ireland or BBA cert in the UK. Without these, they couldn't be considered to fully comply with the regulations because they have to prima facie comply with the regulations. As part of this, and what we've noticed on site, and I was touched upon in the first presentation, is that not all elements of structure have been tested not all elements of a build rather than elements of structure have been tested. So particularly around different types of junctions haven't been tested. It's very hard to test every type of junction, but this can lead then to queries on site and delays on site, and then sometimes a method of construction not being used because we don't have full testing for that type of element. The risk in design and construction, the risk that we saw previously is that prior to the introduction of PCAR, there was a number of issues with pod construction and timber frame. Mainly that was down to design and ignorance on site. I don't think it was builders being ignorant but it was just the knowledge factor wasn't there. So a lot of pods and large developments weren't going from floor to ceiling and left gaps above them. And in timber frame, then the fire ceiling with regards or the structure when it was built didn't meet the full requirements of IS 440. Currently, the main risk we see on site is, and what building control and fire departments come back to us, you'd be looking at different types of methods of construction, and you have a ventilated cavity, and then what product has been used on site or what is specified to close that cavity. Obviously, you use cavity barriers at different junctions, but the cavity barriers that we've seen on site and we've had to hold up a number of jobs are not appropriate for that method of construction. Like all these types of rely heavily on contractors and designers, and all products should be suitable for purpose and meet the manufacturer specifications. But we do acknowledge that like particularly for residential buildings, the risk of fire has been greatly reduced with the advent of sprinklers and becoming a lot more common. You need to have a tight control of fire stopping when on site, because when we go to site, a lot of stuff is in fire stop property, again using the inappropriate products, and that holds up sign off. Introduction of services through fire barriers always has to be made good. Again, we see these issues commonly on site, that items being broken through and not being sealed properly, again with different products. And part B and part F for ventilation can conflict with when it gets in external walls, because the external wall has to breathe, but then we're also looking at cavity barriers, and then there's open space cavity barriers, and some people are specifying again the wrong products, but it's few and far between. It's getting better all the time on site, and the risk is continuously being reduced because of the learnings of every design team, and everything is factored in kind of prior to site. Key items to note on site: fire stopping of junctions, particularly in timber frame, fire stopping of services, certification of products. A recent requirement of IS 10101, which is it's a new standard for electrical installations, requires where you have a fire cert that meter boards shouldn't be in the escape route. So most fuse boards are generally built into the entrance halls of apartments and duplexes, which is not permitted under this code of practice for this Irish standard. So people should be cognizant of that when designing them. They should be designed and placed into storerooms off the entrance hall. Our conclusion: the introduction of MMC methods construction will ensure quicker delivery of buildings and homes, providing a higher quality, energy efficient, safe buildings. What really needs to happen, and it's great to see Construct Innovate do this, is that systems need to be tested rigorously once off-site, and once on site, any works or additional elements need to be fire stopped properly to ensure compartmentation is maintained. Some systems that we find are more robust than others, and over time, all issues will be reconciled with additional elements affecting fire safety. The added testing and the likes of Construct Innovate will eliminate a lot of the ambiguity around different elements of structure. And again, when you go to site, BCAR and the new BSR in the UK means there's rigorous oversight of all elements when on site, again reducing risk. Thanks for that, and if you have any questions, I'm happy to answer same. Thank you.
Brilliant. Thanks, Owen. It's very good to get the update from Part B, the building regulations and the impacts on there as well, but also lessons learned, I suppose, from working on so many different projects, reviewing it, and things like that.